Hello and welcome back to another episode of Math with Sohn. Today we're going to be doing some inverse trig ratios for some geometry. So the first questions are going to start off with just solve for the angle. And the angle that they're referring to would be like angle B here. And you have to use a very special button on your calculator to do this. It's called the inverse button, but it's also called the sine -1 button or the cosine -1 button or sometimes arc sine. But here's the easiest thing to do. All you have to do is type in sine -1 of the 0.4848 in your calculator, and it will spit out angle B, which is why it's called the inverse button, because it literally just flip-flops the location of both of those, and then it gives you the answer, thus the inverse. So I'm going to do that real quick, and then I'm going to show you the answer, and we will move on. You do need to make sure that your calculator is in degree mode. And then you can do shift sign and then 0.4848, and it will tell you that it is 28.99 degrees. 28.99 degrees is better known as 29 degrees because it says round to the nearest degree. And that is it for these questions right here. All you have to do after that is recognize if it switches from sine to cosine, you need to do cosine -1 instead of sine -1 and type it in, and it will tell you the answer that way. So I'm going to do that real quick. Second cosine or shift cosine to get that. And when we do that, we get 0.7431. We get 42 degrees on the dot, essentially. Okay? So let's see how this looks for a triangle. If you need to find the indicated measure or degree on a triangle, you start it the exact same way you would do before, where you label your opposite side, you label your hypotenuse, and then you label your adjacent. And you go across from the angle that's provided that you're looking for. That's an important key detail. Then you look at the two sides that you have, opposite and adjacent, and you have to think with so, ka, toa, out of those, which one uses opposite and adjacent, and that would be, in this case, tan. Now remember that tan, if it's toa, is tan of the angle, which we'll call x, is equal to opposite over adjacent, okay? So we're going to do tan of the angle, which I'm calling x, would equal 27 over 38. Now that's just fancy writing, okay? You don't actually have to overdo some of this stuff. You could just do tan -1 of the opposite over adjacent right away. You don't have to physically write it out unless your teacher demands it. So I'm going to do that. I'm going to do tan -1. And then if you have a fraction button, that would make your life a lot easier to type it in with the fraction button. But if you don't, you can just do 27 divided by 38 if you do not have the fraction button. You do have to make sure you do it correctly, though. So this is going to be 35.4 degrees. And this one also said round to the nearest degree, so that would be just 35 degrees. All right, let's do another one. Let's do number 12. I got a lot of space for number 12. You got your opposite side here. You got your hypotenuse here. You got your adjacent there. You have to look at so katoa. So is what we're going to have to use this time because sine uses opposite and hypotenuse. And if you look here, opposite and hypotenuse are the two numbers that you have. You don't want to use the adjacent side. That doesn't have anything. Sine -1 of opposite over hypotenuse. The opposite is 40 over 42. You can type that in as sine -1 of 40 divided by 42, and it would do the same effect. And that gives you 72.24 degrees, better known as 72 degrees for rounding to the nearest degree. Okay? Let's do another one. Let's do one from the back side, because that's when the triangles start looking a little wonkadoodle. Okay, so notice how here we got our opposite side that is really over here because you got to go across from that angle to get your opposite side. And here's a hypotenuse. And there's the adjacent. We have opposite and hypotenuse again. Sine is opposite over hypotenuse. And this will equal the angle when you use sine -1. So we're going to do sine -1 of 12 over 24. Sine -1 of 12 over 24, I believe, is either 60 or 30. Let's see which one it is. Sine -1, 12 divided by 24. You could also do sine -1 of 1/2 because that's what 12 divided by 24 is, but it was 30 degrees right on the nose. All right, let's try 16 on for size, and then we might be calling the video a little bit short today. We got our opposite side is blank. We have our hypotenuse over here, which is across from the 90, and then we have our adjacent side. So here we use adjacent and hypotenuse. Remember that ka in katoa is cosine of the angle is equal to the adjacent over hypotenuse. So we are going to use cosine in this case because we have adjacent and hypotenuse. So cos -1, 13 over 20, spits out our answer. Let's see what it is. I don't know what 13 divided by 20 is. By the way, if you flip-flop those, it will tell you invalid dimensions. Okay, so I'm going to show you that real quick, what I mean by that. So like if you flip-flop the adjacent and hypotenuse, your calculator will tell you wrong. 20 divided by 13, domain error, and it'll even let you go to it, and it looks exactly like you just typed something in wrong. So if you're getting that message, that means that you're just flip-flopping your adjacent and hypotenuse, and that would happen for sine and cosine. Tangent, you won't know you're messing up, okay? So, I got one more problem at the bottom. We're going to do the critical thinking problems at the bottom, maybe 26 as well. It says, find an angle where sine of x is equal to cosine of x. Well, you got to think about that for a second. Well, sine is the opposite over the hypotenuse, right? And cosine is the adjacent over the hypotenuse, and technically it's the angle. So notice how the hypotenuse is the same here. And if the hypotenuse is the same, the hypotenuse cannot change. The only way that this is going to be true is perhaps if the opposite and the adjacent are the same. I wonder if that would be true. So, and what would happen, and when would that be the same? Well, that would be, these two sides would be the same if it is a 45-45 triangle. And let's test this out. So if it's a 45-45 triangle, this could be like, I don't know, let's say 1. And this could be 1. And then this would end up being, if you use the Pythagorean theorem, 1 squared plus 1 squared would equal c squared. It would end up equaling 1 plus 1 is equal to c squared, or 2 is equal to c squared, which is the square root of 2 according to special right triangles as well as the Pythagorean theorem. So let's see if that's true. What is sine -1 of opposite over hypotenuse? So that would be 1 over the square root of 2. Does that in fact equal 45 degrees? I'm pretty confident it does, but let's make sure. Sine -1, 1 divided by the square root of 2 in my calculator is 45. Now let's see if that's the same for cosine. 1 divided by the square root of 2 is also 45. So the angle, I wanted the angle, is 45 degrees. All right, so let's see if this other one's going to be worth it. It says, draw and label all three sides of a right triangle that has 40-degree angle and a hypotenuse of 10 centimeters. Well, I'm not doing that because I don't want to use an entire sheet of paper to draw something with 10 centimeters. So that is going to do it for this one. Until next time, everybody, stay positive, and I will see y'all later. Bye.